It's a Friday, and we are going to finish our training. As others join, let me welcome our facilitators, my colleagues from Ruforum, and Professor Rogerio from Mozambique to this training. Let me allow Professor Rogerio to give us our remarks for day 5. Professor, over to you.
Good afternoon, everybody. Good afternoon, Forum Secretariat. Good afternoon, facilitator. Good afternoon, participants. We are coming to the end of our training course. It has been a wonderful week. Although we are going to still have a session today, but from what I've seen from the interaction from the facilitators with participants, I've seen that it's a wonderful week, meaning that our choice of providing R, it has been a good choice because we identified a course which comes to meet the needs of the participants. Let's expand, deep dive in this training and explore as much as possible this last session so that we end up here today with really a deep understanding of how R works. In 2 weeks' time, we will be offering a training in advanced statistics and experimental design. So I would like to invite you to participate on this because I believe that R will be using again in this kind of training. So it will be an opportunity to implement and practice the use of R. With these words, I would like to wish you a wonderful session today, which is the last one. Thank you very much.
Thank you so much, Professor Rogerio, for the remarks for day 5. I would like to remind the participants that we are going to post the link for registration in the chat. So keep looking. In the chat, you will see the registration link. And again, the training materials will be in the same folder, which we've been posting for the past 4 days. And the WhatsApp link, we kindly request the colleague who created the previous link to share with us the link so that we can share with others who want to belong to a community of our specialists. So we shall be, those ones who have any burning questions, you can put them in question and answer, and our facilitators will be happy to respond to you. We shall also be sharing the YouTube link for others who can also share with their colleagues who will not have managed to attend this meeting because this platform can only accommodate 1,000 people and others following from YouTube. At this moment, I want to welcome our facilitators to take us through today. Professor Susan Balaba, over to you.
Thank you, Dr. Runyararo. Thank you, Professor Rogerio. Thank you, the Reform Secretariat and my colleagues, the facilitators. We are happy to come to day 5. Not so happy because we had planned for a lot, but we have not been able to cover everything. But I think it's better you cover little when people understand and they pick up something than covering a lot and people are not able to practice and even open a folder in R, or even open a file. So today we are going to finish practicals for exploratory data analysis. And I'm promising that we could use 1 hour, I promise myself, so that we can let Dr. Thomas Odon come in with something new. I believe even if you get the theory, it will set a pace for you for the next training. But in case we do not have that time, we will cover it the next time the training is offered. We also going to send out a short evaluation in the chat and also in the link for where the materials have been posted, so that you can fill in and tell us how you feel about the training, what changes you want us to make. In future, if there are any other training, how should we organize them? So that's the short evaluation we want you to do to give us feedback so that we can improve the training. Okay, let my colleagues, okay, like 1 minute, Dr. Thomas, you can say a word.
Yes, good afternoon, everyone. Thank you very much for persevering through the week. I see a lot of energy. I've been in the WhatsApp group yesterday, this morning at around 3 a.m. There were people exchanging view, asking so we continue with the training on WhatsApp the whole night. So thank you very much for people who put in a lot of efforts. And with ARA, you need a lot of energy. And please, whatever we don't cover this week, we're going to push it to the second part of the course. At least this first part of the training was meant to get ourselves acquainted with ARA and ARA Studio. And after that, we are going to proceed a little bit into details. So please enjoy the day. And then we'll continue to interact. Thank you.
Hi, everyone. It has been great having you since Monday up to where we are. I strongly believe that you've really learned a lot given the sharing and what you've been sharing with us. Keep up the spirit and then continue to learn with R. It's really a nice program that you can always use depend on any topic that you want to do. It is really a very strong program. So I encourage you not to lose hope, but keep on practicing until when you get familiar with the things that we are teaching. After some time, everything is going to be on your fingertips. It's about experience and the time that you give it.
Okay. Thank you, Thomas and Helen. We are going to start from where we ended yesterday. We are going to R. So please turn to R, open your script called EDA. And in case you've just joined today, the script is under the folder. The Google link will be provided for you to download the script that you use and the data set. Okay, so today I believe you revised the whole night and we are going to move at a faster rate than yesterday. Yesterday we were crawling, today we want to walk. So what we are going to do first is to load the packages. Every time you open R, you have to remind R that you want to use these particular packages. So from line 12 to line 19, you can just highlight, and run. So if you have all those packages installed on your laptop, they will run, and loading packages does not require internet once you've installed the packages. So after installing the packages, we are going to set the working directorate. And for us to be able to set the working directorate, you go to the session window, you go to set working directorate, and then choose working directorate. So that you've all come to the same stage with me. So session window, set working directorate, and then choose working directorate. So are we all there in the chat? Are we at the same pace? Okay, great. Everybody is saying yes, and that is great. So session window, set working directorate, and choose working directorate. Once you are choose working directorate, click that. So click choose working directorate, and then browse in your computer where your folder is, where the data set is. Okay, the material will be shared. Helen, please, can you share the material, the Google link for the material? Okay, so my data was saved in day 3. That is where my data is. So I'm going to click to the main folder, then I look for day 3 and then open. So when you do that, down here in the console, you'll see that it is saying set working directorate and showing the root of your working directorate. Okay, so since we've done that, the next thing we are going to do is to import the data set we are going to use. If you're joining for the first time, I think you just follow using the script, but you can go back to the YouTube recorded videos and watch them and catch up so that the next week you are up to date. Okay, so I presume everybody has set their working directorate and we are going to import the data. The data we have, the file extension is CSV and it is called employee. So I have named the object employee and assign it to the read command, and this is the file. So I'm running line 31. So line 31, when you run line 31 and you do not have an error, go ahead and run line 32. And it will give you the first 6 rows of your data. So observe the data to see whether it's the correct data. So once you find that the data is correct, that is the data you need to use. Let's go in and now work on what we were doing. We are not going through what we already did yesterday. What we are going to do is go straight to where we ended yesterday. So what we are going to do is do the table command to get our frequencies for job categories. Then we do round off and continue like that. So we are going to start at line 76. Helen, could you share the registration link? Okay. Okay, so I assume that we are all at line 76. We are running a table command for a categorical variable. And if you look at line 76, job is the name of our object, and you assign the table command to the file employee and look for job category. So then click run. And then when you want to view what is job, Simon, I believe I'm speaking at a low speed, but let me decrease it. Okay. So line 76 helps us to construct frequencies for different categories of job category. So if you just place the cursor at line 76 and click run, it will be able to run. And then if you want to view what is in job, just run line 77. So when you run line 77 and you observe the console, you will see the information down here showing clerical, custodial, and manager. Now, these are accounts. And when you're writing a manuscript or your project, you have to present your data in a standard format. And the standard way of presenting counts is percentages. So what we are going to do here is obtain proportions, line 78, then convert them to percentages. We cannot see the console. Okay, I will just, if you see below the studio, let me just clean it and then run job. Okay, there we are. There we are. Can you see the console now? Is it okay? Ladies and gentlemen, is it fine now? Okay. Great. Okay, so now we are going to change these counts to proportions, and then also convert them to percentages. So the standard format of presenting counts in any document is percentages. So line 76 converts your job, the object name, to proportions. You see it's prop.table. So run line 78, and you can see that these are proportions, but we can convert these proportions to percentages so it's more clearer for you to communicate that information to the audience and say that maybe 76% are clerical and manager, we have only 17.7%. So line 79 helps us to convert our prop.table proportions into percentages and also round up to 2 decimal places. So line 79, if you run it, you get a table with percentages, and it's clearly showing that in that particular company, most of the people are clericals, and the least employees are custodial. Okay, so we are going to do data visualization, which my colleague has already done. And we are going to do a bar plot, line 87. It's a bar plot. And for you to be able to do a bar plot for a categorical variable, you first of all create a table. So you can see we put bar plot is the command. The second command is for you to formulate a table for gender. So let's run line 87. So if you run line 87 in the plot window, you see the bar graph indicating female, male. So it clearly shows us that in that company, there are more male than female. As yesterday I was mentioning, if you produce a graph, don't produce a table in the same manuscript or project. Choose one of them. And we want now to make sure we are using percentages. So line 88, you can see it is saying, draw a bar plot, round off the percentage to 2 decimal places, and the proportions, convert them to percentages. So that is the line 88. So if we run that, we see that in our plot window, we have the percentages. We see clearly that clerical has the highest percentage compared to custodial and manager. Okay, so let's continue and also draw a bar chart using other methods. So assuming you want to present a horizontal bar chart, you go to line 95, and line 95, if you run it, then you're going to tilt your bar horizontally. But remember the audience you're presenting your information to. If they are politicians, it would be nice to do some of those horizontal ones. But if it's academic, then it is better you do the vertical presentation. Then you can also construct a pie chart, line 98. And the command is pie in bracket table, employee is the file name, $sign means call that particular or consider job cut in the file employee. We are also giving it a color, different colors of gray, so that you are able to identify the different colors of the slices of the pie chart. Okay, so we are going to run line 98. So if you run line 98, you see that you have a pie chart with different shades of gray, indicating the different categories of job. But it would also be nice if you can choose to use, Enoch, that is great. Enoch has changed the colors to green, gray, and gray 60, which is okay. You can use red, you can use blue, and it's always, you can, if you don't know where they get those colors, you use the palette. So you can put question mark palette and you will see those colors in R. Okay. Okay, then let's continue. And let me see in the chat. Is everything okay? Is my speed fine? Okay, great. I can see one no. Okay, let's go on. Thank you very much. Somebody says not okay. If you're not okay and you have a problem with the R, please. Somebody is saying, why do we write numbers? I think to differentiate them from different colors, color shades. For example, there is gray, the lighter one, and then gray, the dark one. So to differentiate them, they are given those different numbers. Okay. Error object, that means that you didn't, if you have an error and it says object not found, one of the possible likely things is that you have not imported employee, and the second one, you didn't run the lines before where job is named as that is line 76. So go and run line 76, and then you can run the rest to work. Yes, you can get the colors from the palette. There are so many, you can choose from that. Okay, so let's continue. We want to do some frequency tables. We've been just doing tables. We want to do frequency tables, proportions for job cut. We've already done that, I think. We don't need to repeat that for frequency tables. I think let's go ahead and start on the plots. So we want to construct a plot for one variable, which is salary, which is a continuous variable. And when we go to line 116 and run that line, we'll be able to see a scatter diagram of salary. So if we look at that scatter diagram, it doesn't make any sense really, because we have only one variable where we've drawn the scatter diagram. It's just giving us a random scatter of points, which are some merged together, indicating that that is with the range within which those salaries are. And then we have here these ones which indicate that they are far away from these observations, which may be in outliers. Okay, let's go ahead and add some beauty to the graph. If you want the dots to be blue, just put in type equals the dot 0, and then the color should be blue instead of the default, which is black. So line 122 does that. This is just to, you can see what happens if you want it like that. Or you want to put a title, main title is salary, and we are saying color the title red and the font size is 4. So the rest of the things are just for beautification of your graph. So you can look at the graph and see the salary is in red and the font is 4. Okay, so you can change many things. Giving options. The other thing is, if you want to learn more about the options, you can either go to Google and just put in descriptive statistics using R, or exploratory data analysis using R. Or if you want to be specific, you can say graphical methods using R, and you're going to get so many examples and audios coming up, and you listen to them and you're able to learn more. So the other graphical method we can use is a box plot. And in this case, we are looking at two variables. We want to establish the relationship between two variables. So we want to construct a box plot of salary against job category. Okay. So yesterday we said a box plot is a 5-number summary consisting of the minimum, the first quartile, the median, the third quartile, and the maximum value. So in line 132, the command is box. Can you please repeat the color part? Okay, my colleague will answer that. So the box plot command helps you to construct a box plot. And the first part of the command is that salary is a function of job category, because you want to find out the relationship between salary and job cut. And then you specify the data, and the main title is salary by job cut. Then you label the x-axis and the y-axis. But also remember that when you're presenting a graph in your project or your manuscript, you put the title below the graph. So you may not necessarily need to use main. You can remove it so that you don't have to suffer editing the graph after you've drawn it. So when you're going to use the command, make sure you edit the main title. So if we run a box plot where we are constructing salary versus job category, you can see that we have 3 categories: clerical, custodial, and manager. And it also shows us clearly that manager earns the highest salary, and the next highest is custodial, and the least is clerical. The dark line in the middle of the box is the median value. The lowest value, the first line of each box, is the minimum. The second edge of the box is the first quartile. Then the third edge is the third quartile. And this line here represents the maximum value. Anything beyond the maximum, we can investigate them for being outliers. Okay. We can also use the box plot to see whether the data is normally distributed or it is skewed to the right or left. So if you tilt the box plot, you see that manager, the data for manager is skewed to the right. The data for clerical is also skewed to the right. The data for custodial appears to be normal because the length appears to be similar. Okay, so now we are going to construct a scatter plot for 2 variables. We are going to look at salary beginning and then current salary. So for it to construct the scatter plot, we are going to use the ggplot command, in bracket employee, that is the object name or file name, then plus geo_point. You want points. They are the ones that you're going to use, or you can put line, depending on how you want your graph to be presented. So here we've chosen the y-axis to have salary beginning, the x-axis to have salary beginning, and the y-axis to have current salary. So let's run line 139. So we see a graph here. Everybody should turn to the plots window, which is below the environment, history, and all that window. What relationship do we observe between current salary and beginning salary in the chart? What do you observe in the chart? Okay, positive, linear, strong, positive, proportion. Okay, I can see you have an idea. Thank you very much. So we observe that actually current salary and beginning salary are related, linearly related, and the relationship is strong. It is positive. We can see that there is an outlier here, 1 dot in the corner. of the graph. So you can investigate this for being an outlier using the fence formula, which I gave yesterday. But all in all, we see a simple, a linear regression, a linear relationship between salary and salary beginning. So then we can modify the command above by adding in AES to make it more beautiful. So let's see the difference between these plots. So here we run line 141. Line 141. It has run, but not appearing. Okay, let me run it again. Or let me first clear this. Yes, and then run. Okay, there we are. It's giving us the same thing, just like we saw before here. Okay. Okay. So the next thing we are going to do, we want to get some descriptive statistics by group. And the first thing we do is to make sure our categorical variables are converted to factor. So the first thing you do is to check the structure of the data. Using line 44, STR shows you the structure of the data. So I'm going to run line 144. And you can see that telling you ID is interval, gender is character, birth date is character, education is interval, job category is character. So you know that you need to summarize your continuous data by gender and job cut. So we are going to convert job cut and gender to a factor. So you can use as dot factor or factor. They give you the same result. So when we click line 145, if we run it, we will see that below here, let me just clear my console and run it again so that it's more visible. When we run, we see that it has changed. And when you use the class in bracket gender, it is telling you that gender has been converted to a factor. Okay, before I go to the grouping, can I see in the chat? Is that okay for now? Okay. Okay, thank you. Let's continue with the descriptive statistics, and we want to summarize our data by job category. So you can see employee is our object name. We are using this sign here, percentage, less than percentage. It is called pipe in the R language. So what does it do? It helps us put a lot of commands together in one go. So instead of doing them separately, like you group employee by job cut as one command, then you come to summarize as another command, you put all of them at once and run them at once using the pipe command. So employee pipe, that this pipe, just like the pipe of water, you make sure all the water that you want to lead from one point to another goes through that pipe. So you are telling R that put everything through that connection so that can run. So you're going to group by job category, and then you're going to run, summarize. You can get counts, mean of salary. So we are going to group salary by job category, and we are asking to see the count, the mean, the standard deviation of the same. Then NA.RM is if they are missing values, you should remove them. Excuse me. So let's run that line 151 to 156, and it is runs in a go. So if you run that, you will see below here in the console, you will see that we have job category as well. First column, counts, mean, and standard deviation. So you can copy this and take it to Word document and beautify it, and then write around it. Tell us which category has the highest salary, which one has the lowest, and the standard deviation is just showing us the difference between the observed values and the mean. So if you have a large standard deviation larger than the mean, then there's a lot of noise in your data. You have a small sample size and you need to go and collect more data so that that noise is reduced. Okay. So can we go ahead? Is the pipe thing okay? Okay, thank you. Also, the next thing, we want to draw a box plot, but for two variables. The first time we drew a box plot for salary alone. Now we are drawing a box plot for salary versus job cut. And when we do that, you can either use the command box or you can use the ggplot. And where there is geo underscore, you put a box plot instead of line or instead of scatter. So that is the difference. So if we can run also line 161, giving us the same thing. So this is the box plot. So you can choose which command to use. You can use box plot, you can use ggplot. And if you want to make these boxes to have different color, you can see here playing with colors. Employee X is equal to job cut, Y is salary, color by job category, and palette is equal to put together the first color, the second one, and the third one. So if we run line 164, you're going to see that the box plot have different colors. So it depends on what you want really to know and what you want to present. If you want it to be presented black and white, then you don't need those different colors. We've already explained this box plot and said the middle line in the box is the median. If you want to find out about palette and you don't know, just put a question mark and write the word palette and run. That is line 168. So if you run it, you see in the window where you're seeing graphics, you see that it is telling you about what the palette offers. Okay. And then you can see different colors as you go ahead. So graphics.off clears the plot window. So you can either, yesterday we saw dev.off, now we can use graphics.off. So we run that and our graphics, if you click plot, you'll have nothing there. It has been cleared. Okay, the other thing we are going to do, we want to insert a regression line on our scatter diagram of salary, beginning and current salary. We saw that there was a linear relationship, and we also want to get the correlation coefficient of that relationship. So in this case, we use ggScatter, and the file name or object name is employee, and then x-axis is salary beginning, y-axis is salary, current salary. We are saying comma, add a regression dot line. Then comma, we also want confidence interval. Then comma, we want correlation coefficient. And the method we are using is Pearson. Why Pearson? Because both salary beginning and salary, current salary are continuous variables. That's why we use Pearson. If you had ranks, then you would put Spearman correlation. Okay, so let's run line 174. So we can run that, and then you'll see a scatter diagram. You will see R 0.88, that is the correlation coefficient for salary and beginning salary. And since it's greater than 70%, we conclude that there's a strong and it is positive linear relationship between current salary and beginning salary. The p-value is the corresponding p-value. When you're dealing with correlation, our null hypothesis, those things you'll hear about them next week, is that the null is that there's no correlation between current salary and beginning salary. That is the statistical hypothesis. If you want to change it into research, we can say current salary does not vary with beginning salary, or the two do not relate. There's no association between the two. And then the alternative is that there is an association, or there is a linear correlation between current salary and beginning salary. Okay. So in the script, I've put some interpretation you can read later. Next, we are going to produce correlation values, but the first thing we do is to remove the categorical variables, because now you're using Pearson method for computing the correlation. So we are checking the structure again for the data, and it is back to character. And then we are saying that the new data set is called employee 1 is equal to subset, you subset employee, comma select is equal to minus, you're going to remove job cut, gender, and minority, which are the categorical variables. So let's run that. So run line 197 and then head to see what data you're left with. You can see that in our console, you only have education, salary, beginning, job time, and previous experience. So now we are ready to run our correlation using the Pearson correlation coefficient or method. Now here, you're going to run correlation for all the data instead of running one by one. So we use our object here is RES, assign correlation is the command of the file object name correlation 1. So let's run line 200. When you run, you also run the object, and you'll see that we have gotten correlation coefficients. You remember we had the correlation coefficient between current salary and beginning salary was 0.88. So you can confirm that you've done the right things. But these are too many decimal places, and we want to reduce them. So here we are using the round command, round the object, which is RES, but to 2 decimal places. So if you run line 202, you will see that now the correlation values, the decimals have reduced to 2. We can now interpret it clearly. The first column is education versus all the others. So education versus education is perfect correlation. That's why we have 1. Education versus current salary is 0.66. It is strong. So you can see there's a strong linear relationship between education and current salary. The same applies to education and beginning salary. They have a strong relationship. Then job time and education, the relationship is weak because it is 0.05. Then education and previous experience, it's negative and also weak. So you can go ahead like that, interpreting each variable and writing around them. Okay. Now, after that, we want to run a correlation matrix. This is another alternative to what we did up there. So line 215 gives you a correlation matrix. Before we can have the correlation matrix, we must have installed package HMISC. Now, this package also allows you to run regression. So next week, when we talk about regression, we will use the same package. So I can give you 2 minutes, please install, just put your cursor on line 112 and run, and that package will be installed. Afterwards, you load it. So me, I'm just going to load because it's already installed. Okay, so even if you see red, it's just telling us, warning, this package, for me, this package was built in R 4.31, yet my R is 4.30. So I need to update it.
ggplot is the function with package.
GG2, ggplot2. Okay, so I believe that in the chat, if I can look in the chat, is the package installed for everybody? Okay, great. That gives me, okay, thank you. Thank you very much. If you all, Esther John says no, what is happening to Esther John? Hopefully it's just installing. So 1 extra minute for installing. Okay, great. Remember, when you're installing, you have to be connected to internet, but you don't need internet for loading the packages. Okay, that's great. So let's see, we are about to finish, and my colleague.
I think the same, the EDA.R is empty.
No, it's
No,
not.
it should be, I think, somehow the other challenge opening it. You
It,
should try opening it in a different way.
what they can copy and put it in a folder and then open it. So anybody who has a problem with EDA, the script, the file script, copy it from the link, put it in a folder, and then open it in R. It appears that you've already installed it. Gloria, you've already installed. It says package is in use and will not install. So you just load it by running library. Somebody says report creating employee 1 using the subset command, which you had yesterday and the other day. They talked about subset command, and what we're doing is removing the categorical variables. So if you go back to line 197, you will see that our original object is employee, but we've now given the new object is employee 1. And in employee 1, we are telling the R to subset this employee and remove the job, the categorical variable. How do I get all the script? In the folder, you have everything. You have everything. Whatever we are doing, any changes, they are saved and put there. Are you sure it's not showing everything? Is it true that you don't you see line 215 on my screen? Okay. Oh, not showing all. Okay, the reason why I've done that is to make sure the plot part is not small. Okay, there we are.
But they can follow from the screen.
You have your screen, it's the same thing. Okay, so line 215, we want just produce a matrix, and the object is RES2. You assign R correlation as a matrix for employee 1. So there we go, and run the object. So here we are. We have the correlation coefficients in the first matrix, and the second matrix is the p-values corresponding to each correlation value. Okay. So the rest of the commands is just if you want only extract correlation coefficient, you use $2.R. So if we run line 221, you will see only correlation coefficients. And if you run the next one, you only see p-values. So it depends on what you want to present. Okay, lastly but not least, we want to construct a plot. Many plots in the plot window. I'm going to reduce this because it will complain. Now, if you want to divide your window section, for example, you want to draw many graphs on one paper. So it depends if there are 4 rows and 4 columns, you instruct R that you want the window divided in 4x4 rows and 4 columns. So we use this command pow to divide the window. Otherwise, it will just remain not divided. And then when we plot, we will plot all the variables at a go. So line 228 helps us to plot all the variables at a go. When they say figure margins is too large, just reduce your window for RStudio. You just go here and scroll like that. Or what you do, you go to view and zoom out. Okay? Go to view and zoom out, then that will be solved. So if you look in this plot window, you will see different graphs for the 4 variables that we have. So you can present that in your project. If you have so many graphs and you want them to appear on one graph, you can present that in your table. So you can write around them. You see, this is salary, current salary, and beginning salary. Okay, so that is how it is divided. Okay, so lastly, we do cross tabs, cross tabulation. The object is SA. We use the table command, and we want to cross tabulate gender by job cut. So remember, we did a frequency table, but it only had gender alone and also job cut alone. So we are merging both of them, and it's the table command that helps us to cross tabulate gender by job category. So run line 232 and run the object, which is SA. And let me just clean this console and run the object again. You see that we have a cross tabulation of job category versus gender. So you can now change them to percentages. You can see round prop.table, the object name, which is SA, and it will give you percentages. So if we do that, you can see now we have percentages. Copy this, take it to a Word document. For graphs, if you want to export this graph to Word, you go to this command called export. So let's all have our eyes to the folder where the plots are, and you will see that we have zoom and export. So if you click export, there's an arrow that goes down, and it exposes commands like save as an image, save as a PDF, save to clipboard. So you can save your file as an image. When you do that, you can see it is going to be saved in the folder, which I told R that they are saving. It also has an image extension, so you can change the image extension either to JPEG. Okay? Then you click save. So if you go to your folder where you saved your, so let's go to the folder briefly. Let me stop sharing and I share the folder. Share. So this is where my folder is. It's called SDM. And when I click and I go to day 3, you will see our plot is our plot. It is right there. Is that visible? Or I make it bigger? So you see our plot right there. That is the plot you saved. And if you open it, you can see it has those graphs that are many. Okay. That's how you import your data to a clipboard, or you can copy and take it to a Word document. So Let me share my R and we finish. I think this is the last part. And if you want to clean the environment, you use this command on 445. It's RM in bracket list is equal to ls, open bracket, close, and balance the bracket. So it clears the environment. Control L clears the console like that. Oh, okay. Oh, sorry. Control L. Oh, I know. The language of the keyboard is a bit different. Let me change it to English. And so I can edit. So now I can edit. It's Control L. And let's run it and see. It's still saying no. Control. Okay. CTR. Why isn't it working, my dear? That is the console. If you go here at the broom, you will see it is saying, okay, it's because of the lower and uppercase. It has capital C, lower T, R is lowercase, and L is lowercase. So that's how it is supposed to be. So RL is supposed to be lowercase. Then we run. There's something wrong with my, okay, that's okay. Control L. Okay, I can also do Control L and it clears my whatever. Okay. Then when you want to clear all the plots, as we said, you can use dev off or you can use graphics off. Okay, so that ends our exploratory data analysis. And in the chat, I have 3 minutes. Can we see some comments? Repeat, Prof, how to save multiple graphs. Okay. Okay, now I had removed the graph. Let me go back to the graph. Okay, so there we are. And we draw, oh, I had cleared the environment, so I have to redo everything. Okay, I have to go and re-import the data. So if you're still working, you don't have to clear the environment. Okay, so I have to re-import my data and that, okay, that is fine. Then let me go down here. So we want to redraw those graphs, or we can draw any graph, not only multiple graphs. Let's draw this one here and import and export it. So if you want to take this to a Word document, please go to the plot window. You will see there is zoom. The next to zoom is export. So click that arrow of export. It has 3 options. You can save as an image. You can save as a PDF. You can copy to clipboard. So if I use save as an image, it opens up. So let me show you what it is showing. So you can see that it has brought up the folder where I've been working to, and the file name, it is plot01. So you can actually name it and call it scatter. And then save down here. So from after you've saved, go to your folder and check whether it is there. It is already here, scatter. If you click it, it's there. Now, if you want to take it to a Word document, you can clip it or you can insert that file in your Word document. Okay. and then you'll have your graphs in your Word document. Or you can copy and paste them there. Okay. Okay. Okay, so now we are going to share the evaluation link. My colleague Helen is going to share the evaluation link, and we will give you, in addition to the break, we are going to give you 10 minutes, fill in the evaluation form, and then after 10 minutes, you come back and our colleague Thomas will be with you. Thank you so much. Please go and practice. Practice makes perfect. Thank you very much. You've been so active, and it appears things now are going well because the questions are fewer in the chat. Okay. IQ. Okay, let's Ellen post the evaluation. Please fill in the evaluation form. Stop writing so that you can receive the evaluation. It is important for you and us to modify our training, to check for our mistakes. So please fill in the evaluation form and send it back, and it will help us make the training better next time we do that training. Okay. So Dr. Helen is sharing the evaluation form. Fill it in, we need it. Both you and us here, we need that evaluation form so that we can be funded next time to run another course. Okay? Put it even in the Q&A. Okay. So after 10 minutes, we are going to have Dr. Thomas come in. Thank you so much. And let's meet the week after next week. Is available. Dr. Nyararo, can we start? You with your dogs. Eh? Okay.
Dog.
We are ready to start. Still signing the form, Lolo.
Thomas, I think you can now go ahead. Most of the people must have filled in. Thomas, I think you can now start.
Hello, good afternoon. Good afternoon, everyone. Are you getting me clearly? Can I see from
Yes.
the chat?
We can hear you.
Okay. Yeah. So I want us to change gear a little bit. My colleagues have done a good job. At least we would roughly everyone can access our. I think the fee of our studio has reduced a lot by now. So I want us to change a little bit and try to look at things slightly differently. We looked at exploratory data analysis, where mainly we look at the different trends, look at whether there are outliers, we plotted graphs. So from there now we need to proceed a little bit to do some confirmatory data analysis. So I have some nice example of mine here. So here I have a toy example. In this toy example, I have 4 types of bonds. There's the white bond, there's the blue bond, there's a red one, there's a green one. We want to see which of these bonds, want to test the strength of these bonds. And then we are going to give the dogs to test for us. So from here, we can see that the different dogs, the dogs are all very similar in terms of the size, in terms of the breed and other things. So let's assume now that we give each dog a piece of bones and we set an alarm clock, and then we allow the dogs to consume the bones, and then we record the time. So let's assume that we get this. So we say now, if we look at the white bone, the first dog, say took 15 minutes. The second dog took 13 minutes, and then the third dog took 10 minutes. And then if you look at the blue one, the first one took 20 minutes, the second one took 19 minutes, and then the third one took 22 minutes, and so on and so forth. So what we want to do at the moment is to actually determine whether there is actually significant differences between the time taken to eat the different bones. So if we in form of a table, for example, we could arrange it this way. We could have bone A, B, C, and D. And then from here, we have the replicate, how many times each bone was tested in the experiment. So if we look at A, the first dog gave us 27 minutes. The second dog gave us 28 minutes. The third dog gave us 30 minutes. And then we look at type bone B. We have 15, 13, and 10. And then C, we have 20, 19, and 22. And then for D, we have 40, 42, and 50. So from here, which bone is the hardest from here? Maybe we see in the chart. Based on what you see here before we can proceed, which bone appears to be the hardest? Okay, can see D, because it took a longer time for the dogs to crash. Okay, good, thank you. And which one is the softest bone? The softest, okay, the softest is B. Okay, thank you. Okay, so now if we want now and said, okay, we've got this data from the experiment, and we need now to analyze this data. So we're first going to look at what we call analysis of variance. I know most of you already know what analysis of variance is. So here, the first thing that we need to do is we need to identify the different sources of variation. As you can see from here that these values differ. I mean, you can see the values are not the same, so there's variation. So what are the thing causing variation here? So I need to get a spotlight or... Okay, let me get my mouse, yes. Okay, so you can see here that we first start by identifying the sources of variation. in the data, and then later we partition the different variability. We partition the variability into the different sources. I'm going to give an illustration to actually show what I mean by this. So here, so we have two sources of variation. So the first thing is we have variation within each treatment. So if we look at treatment A, for example, or bond type A, there's variation. Replicate 1 is different from replicate 2, different from replicate 3. So this can be illustrated. So you can see from here, if you look at D, so you can see now that this box plot here will show us the variability that exists within type D. This one will show us for type A, type C, and type B. So which bonds has a lot more variation? Which bond do we have a lot of variation within? Can I see from the chart? Okay, so we seem to see a lot of variability within bond D. Okay, and then the lowest, which one is showing us the lowest variability? You guys are very smart. Okay, good. So we seems to have A and C seems to have low variability. Of course, we can calculate the you already saw how to calculate the summary. I think Prof. Susan did that. So we can put figures to this. So the first source of variability that we see here is that there is variation within the different treatment or within the different bond. Now, the next thing is that we also have variation between the different types of bonds. So, and here we can look at, you can see variation between A and D. If we we compare their center. So this is the variation between A and D. Then there's variation between B and C. Then you can look at variation between A and C, and so on and so forth. So we have two sources of variation. We have variation within each treatment, and then we have variation between the different treatments. So what we are trying to do with analysis of variance here is we are trying to look at the total variability in our data set, and then we are trying to partition this variability into the two components. We have the component that is due to variation within the treatment, and then we have variation between the different treatments. So once we can partition the variability in the two sources here, we should be able to construct what we call analysis of variance table. So we already saw how, for example, to do a preliminary analysis. So here, the first thing we can do here, we can have our box plot, which you already saw how it is constructed. So from the box plot, we can see already that D has the highest median, and then B as the lowest median. You can also, we also have a tables of means here. So you can see from here, we have a mean of 20. For A is 28.3, for B is 12.7, and then C, and then D. Now look at the variance now. So we need to relate the variance, the column for our variance here with what we see in our box plot. So you can see the highest variability is in D, which we all, at least that's what we all indicated. And then the lowest is actually in A and C. So A and C actually have a similar variability in the set. Okay. Now, looking at a box plot is going to tell us, first of all, from the box plot, we can already have a rough idea whether if we go ahead and do the hypothesis testing, whether we are going to actually see that there are differences, we're going to test the significant differences between our treatment. So from here, for example, we can see that maybe D is different from the rest, but for the rest, the differences seems to be minor. Remember, the average for D is about 40, while the rest we have from 29, 28, and so on and so forth. So here we have the mean, we have the variance, we have the standard deviation. So this is what we get from the summary statistics, which we did already with Prof. Sue. Susan, and then later we can proceed and see how we can go ahead and move that. Okay, so let's go to the next one. Okay, so I'm sure all of you might have seen this kind of table here. This is what we call analysis of variance table. So analysis of variance table has different columns. In this case, I have the first column will show for us the different sources of variability. So we have variation between the treatment, which is, so this is the variation between the treatment. We capture it in the first row, and then variation within the treatment, which we capture it in the second row, and then of course the total. So the variability between and within will give us the total variability. Of course, we talked about the degrees of freedom. I know you've all done statistics, so at least you've heard about what a degree of freedom is. You know, you can define what degrees of freedom is. And then, of course, if we are looking at, we're analyzing variability. So to analyze variability means we need to calculate the variance. And we all know the formula for calculating the variance is given by the sums of squares divided by the degrees of freedom. So here you have the second column talks about the degrees of freedom. The third column talks about the sums of squares. And then the third column talks about the mean sums of squares. And then we have the variance ratio. Now, this is what we did theoretically in class. So now we are going to subject our data set to analysis of variance and then generate this kind of table here. And then from there, we can see how to go ahead and draw our conclusion. Okay. So if we put this data set into R, which we are going to see, we are going to generate a table that looks like this. So we can see that, let's look at the column number 3. So we see that the total sums of squares is 1,694.7, what we have down here. And then okay, just hold on a bit. So the total sums of squares is this one down here. And then this total sums of squares has 2 components. We have component within and then component between. So if we go back a little bit to what we had before. So between, that is between the different treatments and within the different treatment. So these are what we actually have here. So this is between, and then this one here is within. And then of course, the mean sums of squares is simply got by dividing the sums of squares by the degrees of freedom. And then we reach a point here. So here we have what we call the variance ratio. Now the variance ratio, as I'm sure most of you know, is we are looking at the ratio of the 2 sources of variation, the variance due to between the treatment and the variance due to within the treatment. So here, what we are saying is that the mean sums of square for treatment divided by the mean sums of square for error is actually 55.27. So what does this mean? So this simply means that the amount of variability due to between treatment is 55 times higher, 55 times compared to higher than the within the treatment. So what does this mean? This simply means that most of the variation that we observe in our data set is due to variation between the treatment rather than variation between the treatment. So, and this is the value that we all know and that we use for hypothesis testing. And from here, the computer will generate for you what called the p-value. So we are also going to see how a p-value can be used to test hypothesis. Are we together? Okay, great. I'm going to interpret I'm going to go further and have that. Okay, so let's proceed to the next. Okay, so yeah, this is the hypothesis that we have here. So we have what we call the null hypothesis, and then we have the alternative hypothesis. Now, the null, as the name suggests, null means nothing. So the null hypothesis simply states that there is no difference between the treatment that you're trying to compare. So we can see that the mean for treatment A is the same as the mean for treatment B, the same as the mean for treatment C, the same as the mean for treatment D. While the alternative hypothesis indicates that at least a pair of treatments are significantly different, that a pair of these treatments are significantly different. So what we do in this case is that we are going to test our null hypothesis, and we're either going to reject the null hypothesis or we fail to reject the null hypothesis. So how do we make that decision? So the first thing is, there are two ways of coming up with that decision. The first thing is, you can look at the F statistics, or you can look at the p-value that ARA will generate for you. So there are two ways of making the decision here. We can either use the F statistics, or we can use the p-value to make that decision. So let's go and see. Okay. So I have here, so how many of you have heard about F statistics or F calculated compared with the, so we have two. We have F calculated compared with F from the table, or F from the table is the same as F calculated is the same as our F statistics. So here we have, so how many people are familiar with the comparison or between F calculated and F tabulated? Okay. Okay. Okay, so let me just try to explain briefly. So what we always do is that for us to either reject or fail to reject the null hypothesis, we're going to go and look at this value here, the F statistics. Now, the F statistics is simply the ratio of the mean sums of squares for treatment divided by the mean sums of squares for within. Now, under the null hypothesis, the assumption is that the differences between the different means is actually equal to 0. And what this implies is that any variation that you observe between the different treatment is just purely due to noise. So what that means is then that the ratio of the mean sums of square for treatment and the mean sums of square for within, the ratio should be very similar under the null hypothesis, because the null hypothesis will say there is no difference between the treatment. Any variation that you observe is purely noise. So in that case, we would expect the ratio of treatment sums of squares divided by within or residual sums of square. We expect that value to be very close to 1. But how close should it be to 1? So we need to set a criteria to determine whether to reject the null hypothesis or not. So the criteria should be we should compare this value here that the data has given us to a value that would be under the null hypothesis. So if the null hypothesis is true, the value of F statistics should be rather small. But how small should it be? We need now to set up a criteria. And this is how, so this is how the comparison happens. So if the F that you calculated, which you call the F statistics, if it is very big compared to the critical value that we are going to pick from the table, that would mean that this value here is much, much bigger than that, then we reject the null hypothesis because the null hypothesis is telling us that there's no differences between the different means. So we would reject the null hypothesis. However, if the F statistics that we have calculated is less than the critical value from the table, then we fail to reject the null hypothesis. So let's look here now. Our statistics that we've calculated is equal to 55, okay? And then the one that we got from the table, the critical value that we got from the table is 4.07. So in this case, what we do, in this case, do we reject the null hypothesis or not? Do we reject the null hypothesis or not? I want to see in the chart. Reject H naught. Okay, so can somebody unmute himself or herself and tell us why we're rejecting H naught here? So who is willing to explain for us here?
Maybe you can identify a person, we promote that one to speak.
Okay, then you guys better stop now of saying yes or not. Samuel Migeka, can you unmute yourself?
Samuel who?
Nobody doesn't just have to unmute themselves, not or none of them can get the. No, that's fine. Let me just proceed. Okay. So let me just try to use this example here. So here we reject the null hypothesis because our F calculated is actually greater than our F from the table. So in this case, we reject the null hypothesis. So by rejecting the null hypothesis, we are saying that at least a pair of treatment are significantly different. Now, when I always go to my local pub with my friends, this is what happens. We set a criteria, we set a level that if you take your beer and you reach a certain level, we set a criteria for us to consider your bottle is empty or not. So now we set, for example, this green point here that say if your bottle, if the liquid in your bottle reaches this stage, then we consider your bottle to be empty. Okay, so this is our F tabulated. Okay, and then F statistic, that's F calculated. So this one keeps on varying as you have there. So here in this case, you can see that our F statistics is actually greater than our F tabulated. So we are going to reject the null hypothesis. We're saying, well, okay. Now, this bottle is important when it comes to the issue. How do we use probability instead of using the F statistics? And remember, when the computer gives you F probability, so it moved from one step from that. So let's move to the next one. So instead of looking at the length from the bottom of the bottle up to the point where the liquid is, if we decide to look at the empty space on top, okay? So here the p-value is, if this is our p-value, and then this big part here is going to be our our alpha. Alpha is the critical value that you set. Alpha is the critical value that you set. So if our alpha is say 0.05, now we need to compare our p-value with 0.05. Now remember, when we are comparing our F statistics with the F from the table, the bigger the F statistics, the more evidence we have to reject the H naught. But here, if the F statistic is very big, it means it will give us a very small p-value. So when we are going to use the p-value instead of using the F calculated versus F tabulated, the smaller the p-value, the higher the chances of for us rejecting the null hypothesis. So here we reverse the order. So if the p-value from your table is less or equal to 0.05, you reject the null hypothesis. Otherwise, if the p-value is greater than 0.05, you fail to reject the null hypothesis. So in this case, for example, our p-value here is much smaller than our alpha. Alpha is the upper part here. So alpha is a lot larger, our p-value is smaller, so we reject the null hypothesis because we have a smaller p-value. If we have a situation where, let's say, for example, our p-value is large up to here, then our alpha is smaller, okay? So you can see from here that our p-value is greater than alpha, so we fail to reject the null hypothesis. That's what we have here, okay? So when we are in what we do practically, when you do that analysis, you don't use F calculated versus F tabulated. You use the p-value versus use p-value versus the critical level, which is alpha. So alpha is always set either at 0.05, which means you're 95% confident, or 0.01, which is you're 99% confident, or 0.001, which is you're 99.9% confident. So from here on, the decision is going to be based on the value that you have at this particular point here. Is that clear? Or if F calculated equal to F tabulated, you reject the null hypothesis, just like I said. So there should be an equal sign here. So there should be an equal sign with this one here, just like I have for this one here. Okay. 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 So now that was the first experiment. Now in my second experiment, I now have different types of dogs. So I have the big types of dogs. I have the second, the medium size, and I have the smaller one. Now we're going to talk about experimental design after next week when we're coming for the second part of the training. This one is just, I want to introduce the idea of blocking. So here, there is differences between, there's going to be variation between the different types of bonds, like what we had in our experiment 1. So remember, in our experiment 1, all the dogs were the same. So the only variation that we have here are variation between the treatments, and then there's variation within the treatment. But here, in addition, we have variation now between the different types of the dogs as well. So this one then will come in with what called a block. So here we have a block 1, which is the big type of dog, and block 2 and block 3. Okay. Osborne. So Osborne needs to be promoted to ask question. So the null hypothesis is always an hypothesis that states a certain fixed condition. In most cases, when we're comparing treatments or we're comparing groups, the null hypothesis always states there's no difference between the different groups that you're comparing. while the alternative hypothesis always state that there is some difference between the group that you're comparing. But the details of how you state it will depend entirely on the level in which you're operating. So for now, we are going to simply restrict it to null hypothesis, mean there's no differences between the treatment, and then the alternative hypothesis, which says at least a pair of treatments are significantly different. Okay. We will, the one way ANOVA, the two way ANOVA will answer that along the way. Okay. So from here, let's get another. So let's say, for example, so let's look at the white bone, for example, here. When you give the white bone to the big dog, they take the dog takes 15 minutes. When you give it to a medium-sized dog, it takes 28 minutes. When you give it to this very small dog, it takes 48 minutes. So you see now, there is variation within the type of but this variation is much bigger than the variation that we observe in this case here. You see the variation within here, within type B is 15, 13, 10. So you see this variation is much smaller than the variation that we have here. This is 15, 28, and 48. So if you assume that the different types of the dogs are not different, then you're going to have a much bigger variation than otherwise would be the case. So we need to introduce another component in our model, which is the block, to take care of the differences between the different types of dogs. So here is a simple way of looking at it. So you can see from here that the big dogs take fewer on average. The big dogs take 28.5, and then the very small dogs take up to almost 80 minutes on average when you look at the difference. So now you can no longer ignore these differences between type of the dog, because if you ignore it, it's going to go to within within treatment variability, and it's going to make within treatment variability very, very high. We are going to see when you're going to look at the practical what happens if you ignore that. And then you still have differences between the different treatment. So you still have treatment D with 95. You have treatment B with 30. So then from here, we can go ahead and do analysis of variance. So so we still is advisable always it's advisable to always first do exploratory data analysis, as Prof. Susan was talking about. So here, for example, if you look at the different types of bones, you can see that bone D is still the highest, but it also has more variation compared to bone B, A, B, and C. And you can also see from here that, well, there is a likelihood that A, B, and C are not different from each other, but they may be different from type D. Yeah. Now, if you come and look at variation between and within the different blocks, you can see that the big dogs take shorter time to crush the bones compared to the smaller dogs. But then you can also see that there is smaller variation between the big dogs compared to between the two types of the dog. So this is part of the information that you can always use when you're going to look at the analysis of variance and you're going to look at the assumptions of the analysis of variance as we are going to see practically. Okay. Okay. So in this particular case, we also have variation between the different treatment. We have variation within the different treatment, but in addition, we also have variation between the different dogs or between the different blocks. So we have slightly more sources of variability here compared to in the first case, okay? So this would be the output from the analysis of variance table. So from here, can anybody, can you type the explanation for this p-value? How will you use this p-value here? Based on this p-value, are we going to conclude that there's no differences between the time taken to crush the different types of bonds or not? Is there a significant difference? Yes or no? Okay, I still see there is a no, there is a yes. Okay, can you stop then? Okay, Emerson, can you type why you say there's no difference? Okay, so here what we are going to do here is we are still going to, this is our p-value. And this p-value, we are going to compare it with alpha. If let's say we set alpha to be 0.05. So we are going to compare this value here, which is 0.001 with the alpha, which is 0.05. So here, because the p-value is less than alpha, we reject the null hypothesis. So rejecting the null hypothesis means there is a significant difference between the different types of bonds. Now, what about the blocks? The blocks are the different types of the dogs. Is there a significant difference between the different types of dogs? Can I get an answer to that? Okay, so it's still the same thing. You can see that the p-value here is less than 0.05, which will still make us reject the null hypothesis. So here we can conclude that there is a significant difference between the different dogs. So this is what I wanted to show you theoretically. So I then want us to go and look at the scripts that I gave you and do some analysis and try to do the interpretation. In case we don't complete, we are going to continue with this after next week. Remember, there is the advanced part of the training, which is after next week. So we are going to pick up what where we've left. In fact, we'll repeat everything that we have done because we'll just to refresh the mind, and then we'll move a lot faster. We assume that by the end of this today, all of you will go and sharpen your ARA knowledge, so that when we start after next week, everything will move much more smoothly. So let me see if I can answer a few questions before we can go to run that. How can we perform reliability analysis? That one you cover it under reliability analysis, please. Okay, so there are things we can, I just want to see a few questions, one or two questions that I can answer. Otherwise, we can proceed. Okay. So are we ready to run the scripts that I shared? So we are going to look at a factorial after next week. So when we talk about one-way versus two-way, one-way analysis of variance is when you're dealing with only one factor. Two-way analysis of variance when you're dealing with two factors. You can have three-way, you can have four-way, you can have multiple factor analysis. So that one we're going to cover under experimental design and further analysis of variance, okay? So say, do you reject when the value is 0.049? Yes, you reject. Because if you round up, you still get 0.05. Okay? So please don't answer a question that you think is going to come ahead of us. Why did we not calculate within treatment p-values? If you calculate within treatment p-value, then you will not be able to test hypothesis because you need that as your noise to test your hypothesis. Okay, good. So now let's okay. I want to ask question. Do we all have the material? Do you have material for day 5? You go to the Google Drive. Those who are saying no, please go to the Google Drive and download the material. This material was posted in the WhatsApp group yesterday in the night, and then this morning it was posted in the link. Now the link is being shared, so please, I'm going to give you 2 minutes. Doris, the link was shared and was shared several times. So now stop posting anything and allow people to first. If you are not on WhatsApp, we are going to put you later on. Let's first download. Okay, 2 minutes for everybody to download. I was observing and I saw a number where people were going wrong. The first thing that I noticed was the issue of setting a working directory. Now, if you don't have the correct working directory, you will not be able to run ARA. A working directory is like a house where all your tools are gathered and you're going to work from that house. So my volume is not clear. I thought I was talking at the top of my voice. So a working directory is like a house, a working room. And in that working room, you put all your tools so that when you want to pick a particular tool, you just push your hand and pick it. Now, if you don't have some tools in your working directory, you can still use the tool. But you need to send a kid to go pick it and bring it for you. And that's why you need now to specify the directive. Say, okay, you go to room B and pick and bring with it. So the reason why we want you to create a working directory is that you have everything that you're going to work in the working directory. So when you tell ARA that I want this data set, ARA will look within the working directory and pick it. Now, if you want to save your work also, ARA will save it within your working directory. So the first thing that we need to do is we need to know how to set the working directory, okay? Is there anybody who still does not know how to set a working directory? Please type 1. ARA refused to listen to you. Okay, so we have a few people who say they don't know how to set a working directory. Okay, good. Okay, so let's stop now typing. Now, the 2 minutes is over. Now, I want to know now, have you all succeeded in extracting the folder for day 5? Okay. Is there anybody who is having a challenge extracting folder for day 5? Do you want to show us your screen so that we can help you? But given that this is the 5th day of the training, I can assume that this is fine, okay? So I want you to, now let's go and we are going to start by setting a working directory. So let me stop sharing this, then I can go and share a different thing. So let me first show you what is the content of the Okay, so this is the content of the folder. There is a PDF file, analysis of variance. There is a file called bond.csv. There is a file called newt.csv. And then there is a file called pollination.csv. And then there is an R script called t-test and analysis of variance.r. Now look at the end, look at the extension. The first one is a PDF file. The second two is a CSV file, and then the last one is the .r file. Now people were asking, why are you all using the CSV and not using Excel or not using any other? Now, no one is going to force you to use a .csv file, okay? You can use an Excel file. You can use your file from SPSS. You can use your file from SAS. You can use your file from Minitab. You can use your file from anywhere that you have. You can have a text file. What you need to know is you need to know how to get that particular data into R. So you need to get the right function that can be used to call it into R. Now, because this one has a .csv, that means we need to use read.csv in order to open that. So do we all have the content that I'm showing you up here? Can I see? Okay, good. Yeah, being a statistician, we believe that not everything will be the same. So the few no's are also okay. Okay. But for 3 point, for later, agriculture should come at the basic on part of the basic function for 4.3.1, I think. Okay, so let me now stop this and go to share the R Studio. A bit. Okay. Okay. So are we all seeing my R Studio? Okay. So okay, good. So can we all open the script, the R script? Please open your R script and see to it that you have what I'm showing here. So there is no plagiarism in R. So you get my script, you can modify it to do whatever you want to do with it. And no one is going to question you that or what. So what you need to do is you need to know how a particular code works. You can go online. If you want to draw a graph, let's say you want to draw a box plot, you go on Google and type, how do I draw a box plot in R? You're going to get even work example that you're going to use. So how many people have successfully opened? Okay. Alan has opened. Okay, good. ARA is one of the most beautiful things that has happened, I think, to academic work now. Okay, so like my colleagues have indicated before, if you've already installed a package, you don't need to install it again. You only need to call it every time that you're going to do analysis. And my advice is, when you want to do an analysis, please create a new folder, put all your tools in that folder, put your data set in that folder, put your R script in that folder, and any description that you have should be in that folder. And then once you have that folder, then you can go ahead and make that folder your working directory. Okay? So now let's go and make our working directory. Okay. Okay. So here, what we do. So to make a working directory, the first thing you need to go to, you go to session. Can we all go to session? After session, just go down. Go to set working directory. And then choose a directory. So the assumption here is that you've already created a working directory and you know where it is, so you can go and pick it. Okay. So you go to session, set working directory, choose a working directory. Okay. So we can choose a working directory. Now for me, I have mine on my desktop. So I'll go to my desktop. I look for day 5 material. And then now, if there is another folder inside a folder, ARA will not read what is in the folder, in those folders. So you need to go to the last folder that has your information, but don't open that folder. You only don't double click on it to go further deep in. So here I've identified my day 5 material, and then I'm going to say open. Now, if you are successful, you should have it in the console written here. Set working directory. So mine is in desktop, and then it say day 5. Can you copy yours and put it in the chat, and we see this command here that you generated by creating? I want to see your command. Can you put it on the chat and we see? Okay, I can see C user Dell. Okay, now if you don't want to go into the sessions and do that, the best thing you can now do is to copy that file, copy that statement there and put it up. I can see everybody successful. This is good. Okay, great. Okay, so that means now we are ready to start our analysis. So the first thing we did, we created a folder. We put all that we needed in the folder. We made the folder our working directory. Now, the second thing that we need to do now is we need now to get for us what are the packages that we need to use in our analysis. Okay. So if you have not installed the packages, then you can use install.packages. Now, one of the biggest issues that the people were struggling with all of yesterday night, I did not want to interfere with your struggle, so I allowed you to struggle. But later on, I got a video that showed you how do I install a package that is not available for a particular ARA version. Okay. So those who tried, they tried installing this particular package here, CWHMISC. Many of you tried and you are getting error that this package is not available for a particular version of ARA. So how do we do that? You need to install another package called DevTools. Okay. Once you install the DevTools package, then you call the DevTool package, and then you need line number 4. Okay. Line number 4, which is install, then a underscore GitHub, and then you have this crank stroke, this program that you have. Once you click this, then you should be able to install. How many people have succeeded in installing that particular program? So let's first start by installing the DevTools. Okay, Stephen Adongo said it works. Yeah, it is not in the ARA script because I wanted you to type it yourself. So Eric, Corey, can you type that and run? I want you to install the DevTools, call the DevTools, and then install your CWH, MICH. Yeah, I can see somebody say tool, install packages, that's okay. There are many, yes, of course, Latif, if you said there is no package, that means you have not yet called that, you've not installed the package. So you first need to install it. So a version of this package so you follow what you're seeing on my screen here and install it. When we are very serious about installing, somebody is telling us to add them on WhatsApp group. Okay, I want us to first install this particular program. Please, there is nothing that you cannot do if you have the internet. Yeah, you need to have the internet and you need to have some courage. Tamara, you install what I have here. Look at my line number 3. Are you seeing my script properly? Yeah, so can you type that and that start with the 2. Some of you are going to be late in heaven. Okay, so I'm going to give you one additional minute to install. You can't find GitHub but did you? I mean, we say ARA is case sensitive. Did you type the small cases or you type with the capital? Okay, install successfully. Yeah, function install is not there because you have not probably installed the DevTools. That's supposed to be in the DevTools. You first need to install the package, and then so you first need to install the DevTools. Please check the spelling is not tool. TOOLS. TOOOLS. So Mary, you first need to install dev tools. Okay, so I think we can now start. You first need to install the dev tools. You cannot call it a library before you install it. Now, if you get an error, means something is not right. No, if you're getting error, means there's something that you're not doing right. Okay. The thing here is then that if you don't have it, then at some point you're not going to run some command, but you're not going to die because of that. Okay. So now we are going to let's now run. Okay. Let's run library agricole. Run the different library. If it tells you it's not there, you need to install it first. Okay. Okay. No, no. Eric, you need to first start with install. Install, you're writing a wrong command. So there's no way you're going to, a library should be with the library, you remove the crank and you remove the thing there. Please check the file that I've given you. Try to run exactly the line that I've given you. It's not install.j, there's an underscore. Okay. Yeah. So, or you can go to tools and then you install the package. Then you can look at the name of the package and that. Okay. So some of this is now going to be, okay, so I'm now going to start running. So I want us to first run. You see my line 18, my data. So here we have my data. And what do we want to assign my data? I want us to use read.csv and then call this file here. Okay, so can we run this line? So if you've run that line successfully, you should be able to see my data and you should be having 20 observations of 3 variables. How many people have succeeded in that? Okay, good. And then yesterday they told you the head, what does a head give you? So when you run head, that is my line 19. It gives you the first 6 observations. If you want to show to get the first 10 observation, what do? Can somebody type for us a command that we can use in the chat? If you want to get the first 10 observation. Yes, I say add, you put the data and put a 10, good. Okay, so now I want us to look at my line 20, which is test t.test. But before that, I've introduced something that my colleagues have not talked about, attach. So attach here works almost similar to working directory. So once you attach a data set, you don't need to mention the name of the data set when you are specifying the variables you're analyzing. So here, when you attach my data set, so when you run this line 21 of mine here, you get, so Ara will go and look at cross-poll in my data. Ara will look at the cell poll in my data. So these two are coming from inside here. So the first thing that we need to do, if you have not yet run line 20, let's first run line 21 and see what will give us. So if you run line 21 without running line 20, it gives you an error. And the error is say, object cross-poll not found. Okay. But once we run attach first, and then we run line number 21, you see a different thing. So let me see in the chat room here. So how many people have succeeded in producing the results here? Anybody with a problem with attach? Okay. Okay. So attach here will mean that any next step that you're going to run from here, Ara is going to look for the variables from the file that is attached. So you only need to attach one file at a time, and then once you finish using, using that, you need to detach it, remove it from the memory so that you can attach something else. Okay. So can anybody, do you know how to interpret the T paired T? Who can tell us the difference between a paired and unpaired t-test? I want a volunteer to tell us the difference between a paired t-test. Yes, Tena. Who wants to volunteer? Please raise your hand up so that we can pick you and we allow you to explain to us. Okay, I say somebody said a pre-test versus post-test. Yeah, that is true. Paired is two-tailed. No, that is not true. Paired is not two-tailed. Paired observation from the same person, while unpaired is from different. Yes, that's okay. Okay, I think now a number of you know what is the difference between paired and unpaired. If you don't know, you go and type t-test in YouTube. You're going to get a lot of presentation that will help you do that. Okay, so here, if we look at the result here, this will tell us that the data is cross-poll and self. So here we are comparing cross-pollinated flowers with self-pollinated flowers. You want to see whether they actually have different, they produce different amount of seed. So here we have the results which give us the T statistics, and then it gives us the degrees of freedom, and it gives us the p-value. Now remember, the p-value is what we use to compare with alpha to decide whether there is a significant difference between the cross-pollinated and a self-pollinated plant. Now, if we look at the p-value here, can somebody tell us whether there's significant difference? How many people think there's a significant difference between these cross-pollinated flowers and self-pollinated flowers? Can I see in the chat? I want to see the yes and the no's. Okay, so there are many yeses and a few no's. Okay, so I'm going to explain that. Okay, so here we are looking at the p-value. So this p-value here is 3 times 3.404 times 10 to the power negative 12. So in terms of 0, that this will be 0.0000000 12 zeros before you get a 3.4. So this is a very small probability, and this probability is less than our alpha, which is 0.05. So that means we reject the null hypothesis and conclude that there is a significant difference between the cross-pollinated and self-pollinated plant flowers. And then it goes and gives us the alternative hypothesis. So the alternative hypothesis here is that the true mean difference is not equal to 0. So the null hypothesis will say the difference is equal to 0. Now, this alternative is rising from how we specify our alternative here. We say alternative equals to two-sided. So you can also have one-sided alternative, one-sided or two-sided. So here it then gives us how many people are not seeing my window properly? Okay, can you see now? No, you have the scripts with you. You follow the scripts and run, and for if you have your own, you should get the same value like what I've got here. So there is no point of you trying to see what I'm doing here. If you're failing to run, let me know. Then I can intervene. Okay. So here, it gives us the confidence interval of the difference between these two, the difference between the cross-pollinated and self-pollinated flowers. So the difference runs from about 3 to about 4. That is a 95% confidence interval. And then, so this is the estimate, the difference between the two sets of flowers. We have the cross-pollinated flowers and the self-pollinated flowers. So on average, this one will tell us that the cross-pollinated flowers on average produces about 3 seeds more than the cross-pollinated. The cross-pollinated produce 3 more seeds compared to the self-pollinated. And this mean of 3.4 has a confidence interval that runs from 3.95 to 3.88. So as you see from here, there is no 0 in the confidence interval. So this confirms that there is actually a significant difference between the cross-pollinated and self-pollinated flowers. So what this study did was they went and tagged flowers from a given tree. So we go and get tree A. We tag flowers, one flower one flower, we tag it, we do self-pollination. And then another flower, we tag it, we do a cross-pollination. Then we wait and count the number of seeds that each of them produces. Now this is paired because the cross-pollinated flower and the self-pollinated flowers are all coming from the same plant. So you can have plant 1 with the cross-pollinated versus self-pollinated, flower 2, plant 2, 3, 4, 5, 6, up to the number that you have in your up to 20 plants in this particular case. Any question? Let me check maybe from the chat. Okay. Why you didn't show us the data, which parameter? Oh. So somebody's saying the problem with the other studio is console area. All information is mixed up. No, the informations are not mixed up. You need to just know how to scroll up. No, the script is not in PDF. The script has a .r, ends with a .r. So you can right click on it and open it with RStudio, then it will open for you. Okay. So now let's change a bit, and assuming now that we are, in this case, we said paired equal true, assuming now that we change and we say paired equal false. So we assume that the cross-pollinated flower and the self-pollinated flowers are not related to each other. But this is, of course, not right, given that we know that from each plant we have 2 flowers. One was cross-pollinated and the other one was self-pollinated. Okay, so let me run this, then I repeat the explanation. Okay, so now this one tells us that this is a 2-sample t-test. So now look here, the t-value now is 1.9. And the degrees of freedom is 38. The p-value is 0.05. So you can see the p-value as changed from 0.000003 that to 0.05. So this is almost hardly significant. So you can see if you analyze your data wrongly, there is a high likelihood that you may draw a wrong conclusion out of your data. So you need to be very careful to consider whether it is paired or unpaired. The pairedness here comes because each pair of observations come from the same individual or the same individual plant, and therefore they are related. So instead of considering each of them to be a single point, each of them to be separate point, it's better to look at them as a single point. That's why we now analyze the difference between the two rather than analyzing them as completely two different sets. So here, you could still say, well, if you round off to 0.05, you could still say this, but this is marginally significant, or it's still significant, but it's completely different from the result we had in our case here. The p-value here is 0.00003 points. So the p-value here is much, much smaller compared to if you had done a wrong analysis. So then after running this, we need to detach. If you don't detach, it will remain in the memory, and if you attach another file, it will cause confusion during the time of the analysis. So let's detach. Okay, so then let's run another simple data set before we can go and run, we go to do analysis of variance. It says pollinator.csv cannot open. I did. Joker Lemu, do you want to share your screen? Does anybody want to share the screen? You're having any challenges? You want to share the screen, please? Let us know. Then we can promote you. So, okay. Okay. So let's run.
Joker has been promoted.
Okay. So can you please share your screen? I can stop sharing. Okay. Unmute yourself and talk.
Okay, have you seen now?
Yes.
The package all perfect, but
okay. Did you set your working directory properly?
yes, this is my work director. I can do again if it's important.
Can you go to session?
Go
to session. I want you to set the working directory again. Okay.
This is day 5.
Okay. No, okay.
Yeah.
No, you don't need to put it there now.
Yes.
Okay. No, once you run it, okay, so go down now. Okay.
I'm done now.
Now, but can you see the difference between the two, line 17 and line 18? What's the difference between line 17 and 18?
17 and the 18.
Look at your line 17 and 18. What do you think is the difference?
Here, this one miss.
So you stop at a higher level. And that's why I said you avoid running this thing from the download. So you need to copy this folder for day 5 and take it somewhere else.
Okay, thank you. Okay, thank you.
Yeah, so that's where the problem is. You can stop sharing now.
Okay.
Okay. Anybody else with the challenge that wants to share? You can indicate in the chat.
We have a raised hand from Nabunya.
Okay, you allow, promote that one.
Nabunya.
There's Alfredo. Alfredo, Jose, can you allow Jose to share the screen? The document for day 3 is together with the document for day 1, day 2. Please, there's no, all the documents you have are there with you, please. Tamara, which package allows the MF row comes with best package. You don't need to have any particular package to do that. So, okay, if Jose is not sharing, then I can proceed.
You declined.
Okay, that's fine. So let me proceed. Okay, so here we have, so we are going to have another data set. So this is a data set of this newts. Newts, they are what? They are like the salamanders. They are different types of. Are they amphibians or they are not reptiles or what? But these small animals that you see them there. Now, so here we want to compare male and female. Now, of course, you cannot have the same individual being male or female. So the first thing that we are going to do here is we are going to call our data set, my data set. Now, note here that I'm using the same name here. So that means it's going to replace the one that we had before. So let's run this line here, read.csv. Okay. I hope you detached my data. If you're not sure whether you detach, you can detach again. If you detach for the sec, you detach, and sometimes it's good to detach until you see the error. You see this error here, say detach is invalid name argument. That shows that you don't have it anymore in. So now let's attach my data file. First thing I'm going to do is to call the newt. And then I attach. Okay, now line 29. Okay. Now what line 29 does is if you want to plot several different let's say you want to plot four graphs. So you can have, I want to have 2 rows and 2 columns. So you can have this. But if I want just one, I can have it as 1, 1. Okay, so let's run this as well. Okay. Now the challenge here is that I have my plot, my window for plot is very, very small. So if I continue to go ahead and do the plotting, it's going to tell me that the margins are too small. So the best thing that I need to do, I need to first just pull it a little bit and then see whether if I run, it's not going to cause me problems. So I can run line number 30. Okay. Have you succeeded in producing the box plot? Let me see how many have succeeded. Okay, good. Literally, once you are already in the working directory, it should be very easy to run all these scripts here. So next time you want to do a box plot, You just need to modify this graph here, put in the name of your data set, put in the names of your variables, and then you can have that. The par command will allow you to draw multiple plots on the same page. So if, for example, I want to draw four different plots, I need to say I want 2 rows, and I say I want 2 columns. So this one here is going to create for me. So let me run this and we see. Okay. So now it tells me the issue of I need to zoom. So you need to drag a bit. Okay, so now you can see I can do the same thing here now. Oh, what am I doing? Okay, sorry. So I can now draw 4 different graphs together because of what I've done there with the par. Okay, so you can see here, I have 4 different, with the same graph, but I drew them 4 different times. So sometimes a journal, you may want for good illustration, you want to put your graphs together, then you can use the par. Now, there are several other options to do that. And one of the R excels very, very well in graphics. So one of the main, the advantage of using R is that you can actually have very good graphics. Any questions that is? There are too many questions. 2 minutes or 12 minutes. Oh, okay. Okay. So we can go ahead and run. Let me just first make this thing small again. Up your size. Okay. So let me just run then the t-test. Okay, let's clean it up a bit and run it again. Let me just try to blow it up a little bit and make it bigger. Okay, so this one tells us that this is the 2 sample t-test. It gives you the t, this is the t calculated. It gives you the degrees of freedom. It gives you the p-value. So you can see from here, our p-value is less than 2.6 times 10 to the power negative 16. And then it tells you the alternative. The alternative here, that true difference in mean between female and male is not equal to 0. Now, this is two-sided because you may be interested in male having a longer length than female. That would be one-sided. So you need to know when to use one-sided or when to use two-sided. That's the implication. We'll talk about this more when we're talking about advanced statistics next week. And then I'm just going to explain only this line. I'll allow you to run my because we need to close. We need 10 minutes to do the closing part of the training.
Is this fair? What is this happening? Plants or flower?
No, this is now this one we are looking at different types of newts. We're comparing the male versus the female. So the 2 samples that we're comparing, male versus female, are not related, and therefore this will become our independent or two sample t-test. Now, in the first example, we looked at a flower that is cross-pollinated with a flower that is self-pollinated, all picked from the same plant. So that means from each plant, we have 2 observations. These 2 observations from the same plant are related. That's why I say they're paired. They're paired by the fact that they come from the same plant. And therefore, we'll be interested in analyzing the difference between the 2 while here we'll be interested in analyzing the mean of the two groups separately. Okay, so I think we can stop here. The assurance is that we are going to pick up from here, exactly here, in the next training. So we encourage everybody to register for the training so that we pick up and we continue. Thank you very much. I take you back to my boss. Professor Susan will take you back to our big boss. Thank you.
Thank you very much, participants. It has been a great week to share with you the knowledge of R. I believe that you have gained a lot. You've gained some skills. Now you can start using R for your data analysis. I would like to thank my co-facilitators, Dr. Helen and Dr. Thomas. Thank you for the group job done. And would like also to take this opportunity to thank Reforum, to thank the World Bank, to thank the University of Food Science and Nutrition. Thank you very much for funding, for organizing this training, for giving us an opportunity to facilitate during this training. I wish you well. Please practice so that when we come the week after next week, we just continue from where we stopped. We don't go backwards and lose on time. So practice, and if you get lost or you get an error, copy the error, paste it in Google. There are so many people getting the same error that you will get, so you will get answers to your errors. Thank you so much. I would like to hand over to Dr. Runyararo or Amitu.
Thank you so much, Professor Susan Balaba, for this session. It's been so wonderful, and I'm seeing from the chat people are thanking you a lot. You've done a great job, and we hope to continue for the second session. Professor Rogerio, unfortunately, is not with us, but he's also grateful for these amazing sessions that we have had. I would like to thank Professor Susan and her team for the 5 long days of training, and I'm sure all of us have really managed to get something out of this. I also urge you to go back to the YouTube and try to practice for yourselves and get to know those steps which we're failing to get before you go to the next session. I would also want to thank my colleagues here at Reforum Secretariat who have been working so hard to make sure that everything goes on well. Thank you so much, everyone who has managed to participate in this training. We hope to see you again in the next training. Thank you so much.